right, y'all, welcome to your unit quiz review over our linear models. We've got three main topics to go over today. So I'm going to do the practice problem on the left, and then you're going to do the problems on the right on your own when you see the pause and practice sign. So first one we're looking at is finding our gradient using our slope formula here, where we've got y2 minus y1 over x2 minus x1. So our change in y over our change in x, and we're given these 2 points. So it says find the gradient of the line that passes through the points 4, 6 and 5, 1. Remember, our coordinate points are always written as x, y. So the first value is always x, the second value is always a y value. Okay, so first thing that I always do is I label my points. So if I'm looking at 4, 6 and 5, 1, I know that this is x1 because it is the first x value, and this one is y1 because it is the first y value. And here 5 is x2 because it is my second x value, and 1 is y2 because it is my second y value. So from there I can just plug it into my formula. So I know that m is equal to, so based on my formula, m is equal to, I always draw the fraction bar first as well. So y2, so y2 is 1. Minus y1, which is 6, over x2, which we said was 5, minus x1, which we said is 4. Okay, so from there you can just simplify your fraction. If I plug this into my calculator, let's go to calculate, but I do 1 minus 6 gives me -5. So -5 on the top of my fraction. 5 minus 4 gives me 1 in the bottom of my fraction. I know that my fraction bar means division, so I do -5 divided by 1 gives me -5. So my final answer is m is equal to -5. Okay? So we've gone through this example problem together. I want you to pause and practice and go over these 3 example problems. When you are done with these 3 problems, you are then going to move on to the next part of the video. Okay, moving on to the next part of the video, assuming you paused. Hi, welcome back. I missed you so much. Next one we're working with here is our multiple representations. This one's a lot of calculator work. We always start with our equation, or we have always started with our equation, and we want to label 2 important points, our gradient and our y-intercept. Remember this equation when it looks like this with y by itself? Y equals mx plus b. It's what we call our slope-intercept form, where m is the gradient, or the slope, and b is the y-intercept, or where the function touches or crosses the y-axis. So m is always the number that's being multiplied by x. So here my gradient is -1/2 because that's the number in front of x. And my y-intercept is 3 because that's the number in the b position. From there, I can generate my table of values. You can pick any values you want for x. So this time, I'm going to pick 2, 3, 4, 5, and 6. Okay? Just because you can pick any values you want for x. It doesn't matter. So what I'm going to do here to generate my table of values, I'm going to show you how to do it on the calculator. Most of y'all have seen this. Usually we just take our x values and plug it in for x to generate a y value, but I'm going to show you how to do it on the graph or on the calculator. If you go to New Document, add graphs, and then type your function in exactly as you see it here. So I've got negative 1 over 2 x plus 3, and then hit enter. And then I'm going to press Control T to look at my table of values, and that pops up the table of values for me. So I started with an x value of 2. For my x value of 2, my y value is also 2. For my x value of 3, my y value is 1.5. For 4, it's 1. For 5, 0.5. And for 6, it's 0. Okay, so that is my table of values. Every x value has a y value. Okay, what I'm going to do next is translate that into a graph. So we're going to plot our points that we've generated in our table to create a graph. So I've got the point here, 2, 2. Remember that x is our left and right values. Y is our up and down values. So 2, 2, I'm going to go 2 units to the right and 2 units up. For 4, 1, because you don't have to plot every single point, so I'm just going to plot the whole numbers. For 4, 1, I'm going to go to the right 4 units, so 1, 2, 3, 4, and up 1. And for this last one, 6, 0, I'm going to go to the right 6 units, and I'm going to go up and down 0 units, so stay where I am. Based on these 3 points, I can sketch a rough sketch of the graph. It's going to look something like that. Okay? Now that we've finished this example problem, I want you to pause and practice, work through this example problem. When you are finished, go ahead and move to the last page. Okay, assuming you have paused and practiced, we are moving on to the last problem. Now, this was the one that gave most of us the most trouble on the days that we were working on writing the equation of a line given a point and a slope. Remember our equation of a line we want to write in y equals mx plus b form, where m is the gradient and b is the y-intercept. Okay, so that's the form that we are trying to get our final equation is. And we are going to use our gradient formula to write it in a slope-intercept form. So the question says, find the equation of a line with a gradient of 1 over 3 that passes through the point 6, 9. Okay, so first thing you need to do is label your variables. I know that the gradient is the same thing as m. So I know it says gradient of 1/3, so m is equal to 1/3. Okay, passes through the point 6, 9. Well, I know from doing this problem before that this is an x value and this is a y value, so I'm going to call this x1 and y1. So x1 is equal to 6, y1 is equal to 9. Okay, so from there, I'm going to label my variables, and this should say and plug them in. So label my variables and plug them into my formula. Okay, so I'm going to do that. I know for m is the same thing as 1/3. So wherever I see m, I'm going to write 1/3 is equal to my fraction bar, y2. Now, I don't know what y2 is yet, so I'm going to leave it as y2 minus y1. Well, I know a value for y1. It's 9. So minus 9 over x2. I don't have a value for x2 yet. So x2 minus x1, which is 6. So x2 minus 6. Okay. So now I've set it up. I've set it up just like this, and I want it to look like y equals mx plus b. So what I'm trying to do is get y by itself. The first thing that I'm going to do, when I have a single fraction equal to a single fraction, I can cross multiply. So by cross multiplying, I'm going to multiply the top of the first fraction by the bottom of the second fraction. So I'm going to multiply these together. That's going to give me 1 parentheses x2 minus 6. Okay. And my second one, or the other side of my equation, I multiply the bottom of the first fraction by the top of the second fraction. So that's going to be 3y2 minus 9. Notice that I put these in parentheses because 3 is multiplying by both the y2 and by the negative 9. Because these numbers in our first fraction are multiplying by both the numbers in our second fraction, we have to use our distributive property. Okay? Distributive property is going to be multiplication of everything inside the parentheses. So I'm going to take 1 and I'm going to multiply it by x2. I'm also going to multiply it by -6. I'm going to take 3 and I'm going to multiply it by y2 and multiply it by -9. Now, if it helps you remember multiplication, in front of this x2, we can write an imaginary 1. And in front of y2, we can do the same thing. Write an imaginary 1 in there to help us distribute. Okay, so if I'm looking at this, 1 times 1x2 is 1x2 minus 1 times -6 is -6 is equal to 3 times 1y2 is 3y2. 3 times -9, oops, I meant to do these in a different color, y2. 3 times -9 is -27. Okay, so now I've distributed, but my equation doesn't quite look like my y equals mx plus b form. So the last thing I'm going to do is isolate y, or get y by itself, just like the way that this equation is written. Okay, so I always draw a line down my equal sign. And if I'm trying to get y by itself, the first thing I need to do is look for any addition or multiplication, or addition or subtraction, excuse me. So I see a -27 here, so I'm going to add 27 on both sides of the equation. So these 27s will cancel out. And when I add 27, I want to combine it with its like term. I'm going to add 27 to 6 because both of these do not have an x. Okay? This one has an x attached to it, so 27 and 1x2 are not like terms. So when I add these together, I'm going to bring down first 1x2 because that's not going to change. -6 plus 27, if I pop that in my calculator, I do -6 plus 27. That's going to give me 21. So plus 21 equals 3y2, because my 27's canceled out over here. Now, y isn't totally by itself yet. The very last thing that I'm going to do, I know that 3, if it's right next to y, it means multiplication is happening here. So to cancel out multiplication, I'm going to divide by 3 on both sides of the equation. Now, I divided by 3 on this entire side of the equation, which means I need to divide by 3 on this entire side of the equation as well. Okay? So my final answer here is going to be 1x2 plus 21, all of that over 3 is equal to y2. And now I have y totally by itself, so it looks like my equation up here. If you want to simplify it one step farther, we separate these into two fractions. So this becomes one fraction with a denominator of 3, and this becomes one fraction with a denominator of 3. So it becomes 1x over 3 plus 21 over 3 is equal to y2. These are exactly the same thing. Here we've got the entire equation over 3. Here we've got each fraction has a denominator of 3. Either one is correct, whichever one makes more sense to you. Last but certainly not least, you are going to pause and practice and work on these final two questions on the bottom before we get to our review game. That's all. Thanks for stopping by. Like and subscribe.